All right, so I'm gonna do try two of this video. Unfortunately, I filmed this nice long video and I was capturing on the wrong screen. So, welcome to Binary Adventure, take number 2. We're gonna do a nice laid back walkthrough of Win32 Windows programming related stuff as it relates to reverse engineering. And so, who this video is for is folks who have either some programming experience or are new to it, or maybe who have done a lot of C programming, but they've done it on Linux or have not, for whatever reason, used the Win32 API and Windows native programming stuff. So when you're reverse engineering an application, if you use a tool, you're going to have to understand some of this stuff, or else you won't know what's going on inside of the application. And so we're going to go over a lot of that, not so much the forward programming, but more in a reverse engineering scope. So let's say you open up a binary in a basic static analysis tool like PE Studio, and you see these DLLs. You go to the, you start up here, and you end up wanting to see strings, but you also want to see imports is an important area. So this is the functionality that the program uses. And the reason why this is important is because as long as the program is not obfuscated or compressed, or it otherwise generates or it loads these functions at runtime, they will be in the import address table. And what that does is it shows you some of the functionality of the program, so you can get an idea of what it's doing, and it also shows you where it's doing it. So if you open the program in a disassembler like IDA Pro, you can actually go and look at what it's doing in those areas. So then you see things like virtual query, virtual protect, set unhandled exception, leave critical section, initialize critical section, get proc address, and all this stuff. And you might be wondering, like, what the heck is all this stuff? So that's what we're going to talk about today. And another thing that we're going to cover real quick is I want to show you some differences in what I'm talking about as far as the C code goes, right? So if you learn C in school, or you use it a little bit, or you use it on Linux or for your own applications, the C code you're used to looking at is going to look something like this. See how you have like your typical C keywords: static, void for the return type. We have unsigned integer for the parameters, struct, bool, enum, all these things you will find in a typical C textbook, right? And this, by the way, is some Linux kernel code. So Linux uses your typical run-of-the-mill C. Now Windows does not. It does, but when you start looking at Windows code like this, it can be really confusing even if you already know C, because they use all of these type defs and these pound-defined preprocessor macros for everything. So like PA instruct, HDC rect. Let's look at some more here. WND class, HWND, MSG, HW. You see all these, and they're all in all caps usually. H instance, and you're like, what the heck is all that? L result, callback. I mean, some of them are self-explanatory, but other ones are not. So I'm going to put this in the description, but there's this useful page here, and it explains all of these things. And we're going to go through a couple real quick. So when you see all caps bool, it's literally just the integer. You can see that right there. It's type def to an integer. A byte, all caps, is just an unsigned char. A char is actually just a char. They just changed it to all caps to be consistent. DWord is a type def unsigned long, so it's a C unsigned long. So the point is that if you go to this page, you can see that actually the lingo is just representing your typical C keywords, which you're familiar with. So the best thing to do is bookmark this page like I have, and then go on here, hit Control F, and if you're unfamiliar with something like handle, for example, you can scroll down and find it, and then you can see what it is. So for example, a handle is just a type def pvoid. And then if you look up what a pvoid is, there's a bunch of them on here. Let me go back up. I think I passed it. If you look at what a pvoid is, it's just a void pointer. It's void star. That's it. So If you've done C programming, you know what a void pointer is. And then they have these other ones that are like sound super complicated, like LPCSTR, LPCTSTR, and all this is for example here, a null terminated constant char star. So it's a character pointer. It's a constant character pointer. That's all it is. And then LPC WSTR is wide string constant character pointer, or a wide string, constant character pointer. And then a LPC STR without the W is just going to be your typical string. So you can go and look up the rest of this. I'll put the link in the description for it. So that's the first thing I wanted to cover. So that will explain to you what a lot of all these all caps things are. Now, the second thing I wanted to cover now is actually looking up stuff on MSDN. So say you come in here and you don't know what getproc address is, right? So what you can do is you can just go to Google and go MSDN getproc address. And trust me, use Google. Don't actually use the actual Microsoft website. So I'll show you why in a second. So let's say we click getproc address, and then we go up here, and then we want to see PS create process notify routine, like right here. Well, we click that, and you search, and nothing's found. Or even if it's PS set create process notify routine, which I think is another one, you can still see nothing's found, and you can see that it exists somewhere, but it's not found. And the reason why is because they've modularized their website in such a way where this kind of stuff is going to be in the driver and kernel section of it, and then the user mode functions will be in another section, and then the C# stuff will be in another section. So at any given point when you're doing a search, you're only searching for that section. So it looks like the function doesn't exist when it really does. So you can go to MSDN PS set create process notify routine and see it does actually exist because Google found it right there. So the second thing I wanted to show you real quick is one of these descriptions so you can kind of see what's going on, because this can be really confusing too at first. So this actually is your sort of typical function, but all this garbage looks confusing to you when you haven't seen this stuff before. So in opt, in and out, and all that stuff, these are all basically meaningless to the computer. These don't mean, they're pound defines to nothing basically, or type defs to nothing. And all it does is it's telling the human, okay, this is an in parameter, which means that whatever you're passing in is going to be used internally by the function, and it's not going to be output. However, when you see an out like this is like what you typically will do in C when you pass pointers into data, and then you use that as a way to return multiple pieces of data. So obviously with a return keyword, you can only return one piece of data at a time. I mean, you could return a struct pointer, so you could in effect return more. But what they've done here is that when something is specifically meant to be passed in to be populated and then returned back, they will designate that as an out. Now, what is an in opt? The opt means optional. So what that means is that you could put basically a null or a zero in there. So you can't just leave it completely blank, but you have to put a null or a zero, like I did right here to show you. See, so if you didn't want to pass in whatever this first argument is, an application name, you could just pass in null because it's optional. You can only do that with the optional ones. So that's what that's all about. And then again, you can look up these on that page that I showed you up here. And then they give you this nice little description. It explains what all the parameters are, what they're used for, and then they're gonna give you a description of the return type, if there is one, what value the function will return. And then sometimes they give you this nice extended explanation about what the function does and its purpose and all that kind of stuff. So they don't always do it though. Sometimes it's pretty much blank, and you got to kind of figure it out. It's kind of annoying. And then at the bottom, there are requirements which show which DLL or which library function or which library this function is in. So in order to use this function, you need to import kernel-32.dll, which you could see is basically going on here, because there's a get proc address right here, and there's kernel-32.dll. So if this function was being used, you would see, create process in here, and then it would be next to a kernel-32.dll, which, by the way, is the most common, because kernel-32.dll has to be imported into basically every single program. And so what this is doing is allowing application programmers to effectively do things with the computer, since the operating system ultimately controls the computer, and you are talking to the operating system by using these functions. And so what I wanted to show you is in IDA Pro now, I've opened up all of these system files, which you can find by going to go to your start menu and type C or whatever your main drive is, Windows/System32, and then you can open it up, and you could do a search. So you could do ntdll up here, for example, and you'll find ntdll.dll, kernel32.dll, and what have you. So what I did is I took kernel32, user32, ntdll, and then the actual kernel, which is ntoskrnl.exe. And if you're going to be opening these up in a disassembler like I'm doing and looking at them and messing with them, you're going to want to copy them into a separate folder. So that's what I did here. I created this folder on my desktop. I called it System Files, and I copied those files from the Windows System 32 folder, which, by the way, if you try to find these in the System 32 folder and you can't, you might have to unhide or make visible system files, which you can do in your folder options in Explorer. And the reason why you want to do that is because these are all being used right now as I speak on the computer, and they're loaded in memory, and because there's going to be permission issues if you try to edit them and stuff. And you really shouldn't be trying to edit them anyway, because the system needs them to run, and it's not going to allow you to edit them anyway. So if you want to mess with them and open them up and maybe even modify them or something, you're going to have to do it with copies. And so I've preloaded all those in IDA Pro, my disassembler, because I wanted to save time, because it takes a little while to analyze them. And so let's first look at user32. So if you go to the exports here in user32, you will see all these different functions that can be exported for application programmers to use. So again, going back to this program we're looking at here, that we're trying to reverse engineer, whatever is used by the program will be imported in the program, but then exported in the corresponding DLL. So just to make this a little bit more clear, I'm gonna hop over to kernel32 DLL. So let's say so exit process is in kernel32.dll as it shows us. So that means we could go to the exports of kernel32.dll, excuse me, in IDA Pro, and then we could hit Control F, and we could look up exit process, because you're going to want to hit Control F because there's so many. There's like 1,000 exports or more. So, and then we can find it. We can double click it. We could actually go and look at the assembly code for it. And a lot of them are just going to be stubs to jumps and things like this. And then sometimes you can actually double click that and then cross-reference it by hitting X. And you might be able to get some more information, but a lot of these you can't really get too much internal information from, because they end up being forwarded to ntdll.dll, which is what's called the native API. And basically the way this works is that an application will use kernel32.dll, or should use it, the functions from that, and then kernel32.dll, as you can see here, itself actually imports ntdll.dll, and they're essentially one step lower level functions. And so for each function inside of kernel32.dll, there's often a corresponding function inside ntdll.dll. And ntdll.dll, when we open that up, we can see that it ends up a lot of times, like let's look at ntcreate file. We'll double click it, we'll go to the code, and we'll see this syscall right here. And this is the next thing I want to talk about. So you'll see how it says it puts 55 in the EAX and then it calls a syscall. And what this is doing is this is an actual processor instruction, and it's switching to kernel mode, and it's passing in a code that's associated with this particular function in the kernel. And the lookup table for this is called the SSDT, this System Service Dispatch Table. And I wanted to find the list of functions to show you, but I couldn't find them right now. I know I have them somewhere, but I couldn't find them. So I ended up finding this page right here for this program, which I've never used before actually, so I can't really recommend it. But apparently this program shows you all of the functions in the SSDT. So let's just take the example that they show here. So for nt terminate process, it's index number 257. So basically, if you were looking at a call to nt terminate process from inside ntdll, you would see. Let's do a quick. So this is decimal 257, which is going to be hexadecimal 101. So you would see move 101h into EAX, and then you would see the syscall or the sysenter. They're basically the same instruction. Sometimes it will say sysenter instead of syscall. And we kind of talked about this in a previous video, but basically what happens is it tells the CPU, hey, switch into kernel mode now, and then call a specific function that the operating system uses in order to look at this code, and also take the stack for the function arguments that are supposed to go to this function from the user mode program and pass it into the kernel along with the code. And then what the kernel mode function does is it looks up, it says, hey, let's go and look at this SSDT. What's 257? 257 is nt terminate process. And then it goes ahead and calls the actual kernel function, which does all the heavy lifting and the main work for the computer, or for the operating system to perform this function with the computer. And so I want to show you this in IDA because most of the time when people do these discussions and presentations, they're just showing a bunch of diagrams, but it's kind of helpful to actually see the stuff in the tools you're going to use as a reverse engineer and see how these things all work. Because this knowledge is very useful for malware reverse engineering and just general reverse engineering of binaries on Windows. So that's what I wanted to show you there. And then, so user32.dll is often used for like more GUI stuff. It's a user mode DLL. Actually, ntdll, kernel32, and user32 are all in user mode. So what that means is that although Microsoft doesn't really recommend it, you could, a application programmer can make a direct call to all these functions that are exported by ntdll.dll. Now they're called, many of these are called undocumented functions because it's not just like a privacy thing or it's like trade secrets or something. What it is that Microsoft doesn't want to be responsible to programmers for these functions. So what they do is they provide the other DLLs like kernel32.dll, user32.dll, etc. And officially, application programmers are supposed to make calls to those functions, and that way Microsoft, if they want, can change these functions around and mess with them, and it won't break applications. It won't break your as an application programmer, your code won't break because they've made modifications to these functions. And so what they do is they just don't document them, so that way they're not guaranteeing anything to the programmer. That's one of the big reasons why they do that. And so now some of these are documented, other ones aren't inside ntdll, and you'll find that a lot of the kernel mode functions are also not documented, but some of them are because they have to be for driver programmers. Because obviously, if you're programming a driver, then you need to be able to access some of those kernel mode functions, so they have to document those. So another thing I want to show you is if you are curious about the undocumented functions, you could do a search for ntdll undocumented functions, And there's this unofficial website where they explain some of those functions and how they work, if you're curious. So, see nt add atom, delete atom, but this is still not an official documentation from Microsoft. So you'll see many of these from ntdll start with the prefix nt, but not all of them do. Like you'll see RTL and all that. So that takes us to the next point now. So what happens after we have successfully used that SSDT and we're in kernel mode now, and we want to see those functions. So I've actually opened up the entire Windows kernel. By the way, this is Windows 10 64-bit, so this is current stuff here. And there's a lot of functions that are in this file. It's 8 megabytes big. It's huge, but you can see there's just 2,849 exports even. But I wanted to show you this because you will, as a reverse engineer, you'll start to see these really long function names, and they'll be really, really confusing. Like RTL is not empty directory reparse point allowed. Just stuff like this, like RTL get app container named object path. And what they try to do here is they're trying to explain sort of what the function is doing, but it can be confusing, and it's not that simple at all, really. Especially when it comes to malware analysis, and even just regular reverse engineering. You're not always going to know exactly what the purpose of the function is by reading the name. Like PS get current thread Win32 thread and enter critical region. That's kind of a mouthful. So one little tip here that you could use, besides Googling this stuff on MSDN, which some of these you'll see on MSDN, other ones you won't, is you can go to this page right here. You can go to ntoskrnl.exe, Wikipedia. And when you go here, you're going to find this really sweet table, which is very, very helpful. And it tells you what all those prefixes mean. So essentially, the kernel is split up into modules, just like any other type of code. And they prefix all the functions depending on what module they belong to. So for input and output, it's IO. For KI, it's the internal kernel functions that are really only used by Microsoft. KE sometimes will be used by driver developers because they're still internal kernel functions, but they're actually exported to other kernel code. So what I mean by that is that you can't call up KE whatever inside user mode. It just won't work. But you can if you're in kernel mode. ZW is, so that's another thing I'm going to cover real quick. So let me see if I can show you. I'll do nt create file msdn, which is documented, I believe. So yeah, check this out. So when I click this, well, you'll see on here also it popped up ZW create file. So you're probably wondering, like, what's the difference? And sometimes when you go to one of these functions, you'll search for like nt something, and then it will pop up ZW something, and you're like, what the heck? Why does it say ZW? And the reason why is because often they're the same function, and the only difference is that the nt prefix is typically what they want you to use in user mode. So if you're an application programmer and you're calling the function from ntdll.dll, it's going to have mostly the nt prefix. You're going to use nt create file. And now if you're programming a driver or you're programming in kernel mode, then you're going to use the ZW prefix and call the ZW create file. And that's true all across the board. So just because I'm showing these random functions like this doesn't mean that this stuff's all very uniform. So just keep that in mind. And then speaking of the kernel functions now, I'm going to cover another thing. So then if you start really digging deep, you're going to start seeing things like IRP, MJ, create, IRP, MJ, write, and all this, and all these all caps things. And what these are basically macro functions that are used by kernel drivers. And so essentially when you program a driver, you're basically making an API to the kernel so that the kernel can properly utilize your device. So say I build some special cool device, and application programmers need to know how to use my device, or I want to program a user mode application that utilizes my own device. So I'm going to have to specify how to write to the device, how to read from the device, and send data back and forth and all that kind of stuff. And so driver programmers will create their own API that will interface with these standardized functions, which start with IRP. IO request packet is what that stands for. So you'll see IRP MJ read, IRP MJ write a lot, and then let's just look at this real quick here. See IO create file specify, ZW create file, ZW open file. So once again, now you should start getting familiar with the stuff based off of what I just showed you. We just looked at that Wikipedia page, so that IO means input output, and I already explained what ZW means. And it's weird at first; it takes a lot getting used to, but it all is standardized. And once you kind of get the hang of it, it's actually really easy, and then it becomes like any other type of programming, and it's not really scary or anything like that. So another thing I wanted to explain real quick too is you will see these other capitalized things that start with IOCTL. So I'm trying to see if I can find a good example. Like, see how it says IOCTL storage query property. So what IOCTLs are is actually, this is interesting because it shows device IO control, which I was going to show. But anyway, so let's say you have a user mode application and you need to send some data to your driver. Well, you can use the function inside your user mode application called device IO control. And what device IO control, as you saw kind of back there, one of the parameters here is IO control code. And what an IO control code is exactly that. It's a IOCTL. So when you see IOCTLs, they are a way for a driver to. So the driver developer is going to define some codes that will do certain things with their driver, with their device. And you can, as a driver developer, you can define pretty much whatever IOCTL you want. And so these aren't there are some standard ones, but there can be custom written IOCTLs as well. And so if you were programming a driver and then you wanted your user mode application to talk to it, you might define a code which does something particular in the driver. And then you would have your user mode application use device IO control and pass that IOCTL code in there. So that's what IOCTLs are as well, because you're going to see a lot of that if you're reverse engineering lower level stuff, and you might be confused. So, and then it's the LP. The LP thing, we kind of covered that earlier with the LPCTR. That's just a pointer. DW, DWord, H stands for handle. There's all this stuff is just sort of, you can kind of see the naming convention here. So yeah, it's kind of an earful. It's kind of a mouthful for a while, but then when you get used to it, it all will start to make a lot of sense. So I think I covered everything I wanted to cover. Unfortunately, this video is not going to be as long as my original one and not as laid back, because I filmed it for about 45 minutes and then I ended up having the wrong screen being filmed, so I pretty much just had to throw it away. But anyway, thanks for watching, and I hope everyone has happy holidays, Merry Christmas, Happy New Year. And if you have any questions, feel free to post them in the comments about this stuff. And, there's a lot to it, but I'm always open to questions. And also, you can always feel free to hit me up on this website, malwareanalysisforums.com. So thanks for watching, and I hope you enjoyed it, and don't forget to subscribe.